Welcome to the Chiefs Way. Now mash that subscribe button or drop and give me 50.
Hello, YouTube. Because of the state that the world and our country is in today, I've been attempting to harden my home against, a possible EMP. So in my last video, you saw me install the EMP shield. This is the concealed model, which stays inside of your panel and has the remote lights. But since then, I've added these Ferrites. These are high saturation Ferrites. And if you're going to put them on your main lines, which typically you would use 4 Ferrites, I only have 3. I have one on L1, one on L2, and one up here on the ground. Oh, there it is. Typically, you would have one on your neutral also, but if you could see in my configuration, my neutral is actually a bunch of aluminum wires which surround L1 and L2 like a shield. So there's like zero chance of getting a Ferrite around that mess. So I'm just having to go without it. So this is how we're hardening our main electrical system into the house. Now, what else you need to do is you need to go around to your major appliances and apply Ferrites, which I'll show you some more later, to the power cords of all your major appliances, your computers, and you get different sizes. I'll post a link to, it was like a 60-piece kit that I had bought off of Amazon that wasn't super expensive, and there's a bunch of different sizes for the different wires. But if you on this one, you'll see I put a wire tie underneath them so that they don't fall down to where the the open hot connections are. All right, so now let's go take a look at how I'm hardening the emergency backup solar system. And I'll do that experiment for you on why you need high saturation Ferrites if you're going to be putting them on wires like this that are going to be carrying a lot of current. All right, so let's go ahead and conduct that experiment. Now, this is a typical, Ferrite. This is one that splits open, so you would use this in a case where you can't get to an end of a cable. They make other ones which are basically just, donuts, and if you have an end of a cable, you can kind of go in and wrap it around the inside. These are used in place when you can't get to an end, and you kind of clamp it around it. And then I'll run a bead of electrical tape around it several times just to hold it shut. Make sure it won't come off loose and come off. So let me open it up and show you the inside. All right, the inside are 2 metal halves. This happens to be about a 0.72 inch opening. So it's about, almost 3/4 of an inch. I'll show you some other ones that are 1 inch and other ones that are 1/2 inch and smaller. Okay, so it's got this metal material in there. And if you look from the side, it's just, just like a tube that's cut in half. And what this is going to do is, as the electricity flows through here, the electricity will get off a magnetic field. And these metal pieces, because of the material, it's type 31. These are type 31, which gives a good broadband, attenuation to pulses and surges and interference. So as it goes through here, the magnetic field around the wire is affected by the metal, which will reduce any spike or real fast change. So the magnetic field that's given off between this and the wires resists any, sudden increase of current flow. Okay, so now I want to do an experiment for you and show you why This is just a regular Ferrite. I want to show you why, and if you're wrapping around like individual cables, why you need a high saturation type. So let me get set up. Got to get the refrigerator running so we pull some power into our inverter so we get some current flow, and I'll show you how these react under high current. Okay, the refrigerator just turned on, and so did the furnace. Bad timing. So if you hear that noise in the background, that's the furnace. But we can see we're pulling like 10 amps from solar, and we're, most of that is going right now to the refrigerator. Okay, none of it's going really into the battery. So what I'm going to do is, I got my Ferrite here. I'm going to wrap it around, and I hope we can hear it with this furnace running on. You hear that? All that current running through there is reacting with those Ferrites, saturating them, and they're like vibrating and jumping around. So if I close this up, we'll get like a real terrible noise. It's hard to do one-handed. Here, let me go ahead and get this clicked up, and then I'll... Now you see it's on there. We got this like strange sound going on. Okay? See, as I move this, we made it even worse. All right? You hear that buzzing? That's the Ferrite is saturating with all that current flow through this cable. Now, see this other Ferrite up here? This is a 1-inch Ferrite, and it's not making any noise. So let's go ahead. Let me go ahead and pop this one off real quick. Okay, and we notice now, even with this Ferrite, it's not making any noise, or it's not vibrating or doing anything funny. That's because there's current going in two directions. So the current kind of cancels itself out, even though it's still, providing, suppression for any transient that would be in there. But it's not, being oversaturated like we just saw with that single Ferrite. But when you get a high saturation Ferrite, it's made a little bit differently, that current doesn't affect it in the same way. So we'll start right here at the batteries. You can see each one of my 6 batteries, here's the other 5 here, has a 1-inch Ferrite that goes around the red and black cable. So any current flow that'll try to come up into the battery, any pulse or any surge, this Ferrite will help reduce that, attenuate that, to attempt to protect the battery. Okay, so each one of these batteries has a 1-inch Ferrite on it. Okay, and now up here, this is a device I got off of disasterprepare.com, and I recommend you go to a YouTube site called the EMP Doctor. He's an actual engineer and does videos, and he produces these products. This is known as a trap. This happens to be the Trap B. TRAP stands for Transient Reduction Auxiliary Plug. Okay, so there's a device in here that if there's a transient, okay, which is like a pulse or a surge or some kind of RF noise, gets on here and starts getting to a high level, this will basically clamp it from the positive down to the negative, reducing that that transient to a point that's not going to be harmful to your system. Okay, this is actually he sells these for your vehicles. You would put this between the positive and the negative side of your battery, and it would help any EMP that was surge through the cabling in your car. This would help reduce that transient. Down here is another trap. This one's called the Trap AC, and it's the same kind of device in there, but this you plug into your AC, and if you get any transients between the ground, the neutral, and the hot line, this will suppress those transients. So I got my AC side of my protected. I've got basically the whole 12 volts protected from the transient, and we got the the input to the battery with that 1 inch Ferrite protected. Okay, so I'll go up here. We got a 3/4 inch Ferrite on our battery cables going into our charge controller. So any surge that might make it past and try to get up into the charge controller will be hopefully suppressed by this Ferrite. Okay, this Ferrite right here, this is a 1 inch Ferrite. This is on the DC cables going to the inverter, so that's going to help protect that. This 1 inch Ferrite is on the positive and negative cable going to our battery charger. Now, coming in up over here, this goes to that AC plug we installed on the back of the house. Okay, and if you can look up there, it's hard to see, so I'm gonna have to get some light up there. I'll be right back. All right, we got ourselves a flashlight. There we go. You can see on the AC cable coming in, I put a 1/2 inch Ferrite on the cable that's going into our kilowatt meter, our power meter. And then also, if you notice, I put a 1/2 inch Ferrite going into our battery charger. So if any power gets induced coming in, it'll be suppressed up here, and then again right here. And here's my solar cables coming in from the back of the house. You can see I actually got 4 Ferrites up there. There's 2 you can see, and you can almost see the 3rd one, and up under the insulation is the 4th one. Because the more you put on there, right, the more you put on, the more protection you're going to have. And a little later I'm going to get into how what happens when you kind of wrap the cables around and make a loop through the center of these Ferrites, how that helps to increase its protection. All right, now let's go outside and see what we actually did with the solar panels. Here we are at the back of the house. You see here's our solar input port and our AC port that we installed. And you can see I installed a Ferrite right here on the line. So remember we got Ferrites on the inside, but if anything's introduced in this cable, okay, which it will be, then this Ferrite right here will help suppress that. Okay, and if we take a walk up our line, you can see I've installed another one here, okay, in like the middle of our run, so that because when the power gets introduced into the cable from a pulse, it's going to spread out in all directions. So we want to suppress it, okay? So if we follow the rest of our cable up here to our solar panel, okay, you pop this open, you see I installed a Ferrite here, okay, and I'll just show you one. On every one of the panels, I installed those are 3/16 Ferrites, okay. They're not anything special, because because I have my panels in series, there's not a lot of current flow here. So we didn't need a high saturation ferrite. I mean, we could use just a regular ferrite. So I got one on the black line and one on the red line right at each one of the panels. And additionally, over at these other set, because I'm using a 3S2P configuration. So we had 3 panels over on the other side in series, and we got these 3 in series, and both of those are in parallel. So if you can see right here, I've got one of those 1/2-inch ferrites on this end also. All right, so let's go in and we discuss ferrites some more, and what the effect you can have on your protection by wrapping the cable. Okay, we're back inside, so let's discuss ferrites. Let's just start with these two. Okay, both of these are 1/2-inch ferrites, so we can put like a 1/2-inch, cable through it, or we can wrap a couple smaller cables in it. But this one, you see, has got much more material than this one. Okay, this one was you buy as an individual piece. They were about $5 a piece. And these are the ones I was using along the the solar panel cable, the solar cable. Okay, I wanted a nice big thick quality ferrite to use there, and the the 0.72s and the 1-inch ones were all this a higher dollar, more expensive ferrite. This smaller 1/2-inch one came in a kit of like 60 ferrites, and for like $16, I think it was. So these are good for putting on your computers and your refrigerators and stuff inside the house. But when you really want to harden something that might be external or a critical use, then you might want to go with the individual more expensive ones. And I'll put in all the ones I've used. I'll put links into them on Amazon. They're not affiliate links. I don't have any affiliation with anybody. It's just the products I'm using because I kind of looked at them and decided they were a quality product. And see, so we got all kinds of different sizes. Like this one right here, if you look at it, it's tiny. This would be good for put on your mouse cable near where it plugs into the back of your computer. Typically you want to put these ferrites on areas that, like where the input to the machine would be, because the pulse would be introduced in the cable from the mouse. So you put one of these on the end where the mouse is and put one on the other end where the computer is, because if it gets introduced in the cable in between, we want to suppress it going into the mouse itself, and definitely suppress it where it plugs into the computer. So this would be used for a mouse. Okay, here's another one. Okay, not quite a 1/2-inch, a little smaller than a 1/2-inch. This could be used for other kind of power cable. This would probably go around the power cable going into your computer. Okay, that plugs into the back. So you put 1 or 2 of these on there. And then here's another one. This is probably around 3/16, but you can see here's the 3/16 ones we used. These are the individual more quality ones. So you see we got much thicker material. These are the ones I put out right on the solar panel that were on the black and red line, 3/16. And you can see that it's just a little bit bigger than these. Okay, but it's all type 31 material, which is a good broadband material for suppressing noise. Okay, so there's all different kinds you can get. Okay, now if you just use this counts as one. So you're going to get the attenuation and suppression you would get from a single ferrite. So let's discuss now how we can get more bang for our buck by wrapping the cables around. See, this picture here, this is all about installation of the RF choke, and what it's basically saying is the more wraps you have, the better. So if we look over here, if we have one loop, we get an increase in noise suppression by a factor of 4. So basically it's like one loop is like using 4 ferrites if you just clip 4 ferrites on that line. 2 loops gives you a factor of 9 or 9 ferrites. 3 loops, a factor of 16, okay? So if you look here, here's one loop on this network cable here, looks like, going in the back of this modem. So that one's one loop, so that's a factor of 4. Here's looks like the power cord. They got 2 loops going through that ferrite. So there we're getting a factor of 9. And over here on this, cable, looks like a telephone type cable. They got 3 wraps through there. 1, 2, 3. So that's going to give us a factor of 16. So that's how you could, increase your protection without putting a bunch of ferrites on there. But you always have to use a much larger ferrite, okay? And it depends on how thick your cable is, how many wraps you can get, to fit inside of there. Okay, again, this one's a 1/2 inch. So is that one. And then these get, smaller and smaller. So let's go take a look at an application that we use these for. Again, you want to put these on, ferrites on my refrigerators. I put like 2 of these 1/2 inch ones on there in that kit of 60. I just put 2 on there on the input all the way down by where the cable goes into the refrigerator, your power cable. You just stack up 2 of these along there. That's what I did, okay? And on our washing machine, our dryer, microwave, our gas stove, still uses electric, so I put a ferrite on there. And let's go take a look at a computer, how we harden a computer. Okay, we're looking at the back of this computer now, and you can see every single cable here. See, this one right here came with something already on it, but I added a second one. Okay, here's the network cable. Put one on there. Okay, here's the power cable. Put one on there. And if we go to the back of the monitor, you see I got ferrites going on the video cable and the power cable going on the back of the computer. Now also, if you have anything plugged in, like a charging cord or anything to one of your USB ports, you're going to want a ferrite on there also. If you have a power strip, you're going to want ferrite on there. Okay, so anything where there's a wire, you would want a ferrite on it, because that EMP pulse, that interference, that energy that's being radiated through the air is going to be introduced into wires. Additionally, that energy will be introduced into the machine itself, but the machine itself is more difficult to protect. So by putting these ferrites on there, you're just putting them on there and hoping where the location of your machine is, that it might be protected somewhat from a concrete wall or something. Because the only way to truly protect the machine itself and not the input to the machine is putting it in a Faraday cage or some kind of Faraday bag or some shielding over top of it, and that'll be tough to do with our refrigerators and everything else. So we just got to protect our home with the like the EMP shield. We got to protect our our solar systems and other things, using ferrites and other transient suppression devices, and just hope for the best. So if you like this content, please like and subscribe, and we'll see you in the next one.